So our next paper is titled Designing a 72 target BCI speller suitable for motor impaired people, and this would be presented by Tutan Nama. And
Hello. Very good morning to everyone. I am Tutandamma from IIT Kharagpur, research scholars under the supervision of Professor Devashish Samanta. So today I am going to present one of our work, designing a 72 target BCI spiller suitable for motor impaired people. So these are the outlines for today's presentation. Let's come to the introduction part. So motor impairment is a partial or total loss of functions of any body parts which restrict individual opportunities in communication. So to bridge this communication gap, several assistive technologies has been developed in the field of human-computer interaction. Although these assistive technology-based input devices have some limitations. So they need a form of physical inputs to operate, which is again a complex task for severe motor impaired person. So here comes BCI as an alternative solutions. So BCI or brain-computer interface is a technique to recording brain signals as a brain image and convert them into control commands for operating external devices. So there are several BCI or brain imaging techniques like fMRI, ECG and EEG. So why we choose EEG? Because EEG is a non-invasive technique, means it doesn't require any surgery, and it is very cost effective and easy to set up. So researchers are exploring EEG based BCI applications and designing control modalities for game, modeling emotions and monitoring cognitive loads, and designing BCI spellers and others. So one of the prospective utilization of EEG-based BCI is BCI speller, which can help a motor impaired person to control any machines through text commands. So come to the literature work. So there are a remarkable works has been done since last 2 decades. So I am highlighting such well-known works in this table. So if you look into the 2nd and 8th columns, so there are the number of target symbols and the number of error correction keys are minimum. So our objective in this works to maximize the number of target symbols and maximize the number of error correction key to provide an efficient error correction mechanism. So come to the proposed work. So our proposed work has 3 subcomponents. One is BCI subsystem, one is speller interface, and one is language model. So BCI subsystem records EEG signals real time from user head and converts into control commands to control the speller interface. And the language model basically helps by providing predictive word and sentences to speed up the speller performance. So our main contribution lies into the speller interface part. So the speller interface starting with the initial window that is called home window, which provides 4 options. One is calibration options for training the BCI subsystem using 4 motor imagery class for an individual subject. And the next is formal text option and the SMS options. So the last one is the closing options for closing the application. So calibration window basically provides EEG stimulus for EEG data collection. So it provides 4 classes motor imagery data collected through LS lab streaming layer protocol from OpenVCI Cyton board or DAISY boards, and then process the signals in backend and create classification models. So these are the this is the formal text window. Here you can see there are 2 layers. In each layer, 27 symbols are equipped in the first 3 boxes, and the 4th box is labeled with toggle. So that toggle operation is used to swap between these 2 layers. So there are in total 72 target symbols we arranged. So the SMS window is similar like the formal text window, but difference only in the language model trained. So suggested text, the difference is only the suggested text and suggested words. So in this work, we equipped 72 targets where 26 letters, 10 digits, space, 6 suggested words, 6 suggested sentences, and 19 spatial symbols are arranged. So these 19 symbols are found to be very useful for error corrections. So a user can input a text correctly, or a user can remove the errors using these correction operators or cursor navigation operators easily. So these are very useful operators equipped in this work. So now let me explain the character selection process. So this initial window, suppose I am going to type the character H here. So my target character is present on the first box. So user have to perform the left hand motor imagery signal. Means user have to imagine the left hand movements. So after imagining the left hand movements, this box will expand. So it will expand 9 characters into 3 different groups. Now our target character is present in the right hand part. So user have to perform a right hand motor imagery, means the right hand motor imagery task. So after right hand motor imagery, again these 3 characters will expand to the 3 boxes. So now our target character in the second box. So user have to perform the both hand motor imagery operations. And after selecting the target character, the interface will get back to its initial position. So this is the character selection process basically. So now move into the error parts and error correction part. So in any BCI speller, there are 2 types of error. One is system error and one is user error. The system error basically occurs when means a BCI subsystem classifies user intention wrongly. So this error can be resolved by building a highly accurate BCI subsystem. And if you move into the user error part, so there are 2 types of error can be performed by a user. One is selecting a wrong character group, another one is selecting a wrong character itself. So this error can be resolved by using the back operation. And the second error can be corrected by the correction and cursor navigation operators. So this is the overview of the BCI subsystem. So the BCI subsystem has several parts. So first part is signal acquisition in real time through OpenBCI Cython boards and Ultra Cortex EEG headset equipped with ThinkPulse active electrodes. So then some basic signal processing parts has been performed for enhancing the signal quality and removing the artifacts. Then the segmentation and feature extraction part was done. So after extracting the feature vector, we have to apply on a classification model. I mean, we have to train a classification model. So in this case, we used sparse representation based classifier. For that, we created overcomplete sparse dictionary from the feature vector and represent the feature vectors in a sparse manners using the orthogonal matching pursuit algorithm. After that, a simple class level descriptor is applied to building the classification model. And come to the language model part. So this language model has 2 modules. One is trained for the formal text, where 500 phrases were used to train the model. And the SMS text model we self-created 1,200 SMSs through WhatsApp groups and created the formal text model, SMS text model, language model. So these 2 models are similar, but difference on the just text corpus. Now come to the experiment. This speller work experimented with 3 motor impaired persons, where 8-channel OpenBCI Cython board is used and OpenBCI Ultra Cortex headsets equipped with ThinkPulse active electrode was used. And we use OpenBCI GUI for recording data real time and transfer those real time data through live streaming layer to the user interface. And this user interface was designed using PyQt5. It's a Python library for designing user interface. And the following text corpus is used to evaluate the speller performance. So we calculate the text entry accuracy, character per minute, and correction efficiency. So we found that our model, our work has 5.84 character per minute with 4.828% error. So it means the accuracy is pretty high comparing to the literature survey. So we compare our work with the well-known works and found that our work outperformed most of the existing literature survey or most of the existing works. So as a conclusion, I can say our work equipped a large set of target symbols for a user to select type maximum characters and provides a maximum number of correction operators to easily correct errors. So in future we can modify our BCI subsystem model that the system error can be resolved easily. So these are some references. Thank you.